Today the topic is on addition and subtraction of surds. Just look at some basic idea. If you have 2 apples and if you have 4, you just say it's 4 times 1 apple or 4 apples. Similarly, A plus A is going to be 2A. And if it's A plus A plus A plus A, it's going to be 4A. This is how you deal with variables, and this is exactly how we are going to deal with surds. Let's look at this question. Root 3 plus root 3. It's going to be equal to 2 root 3. As you saw earlier, it was A plus A giving you a 2A. So here it is the same way the surd needs to remain as it is, and you do the addition. Similarly, when you have root 3 plus root 3 plus root 3 plus root 3, obviously the answer is going to be 4 root 3. Looking into addition of 3 root 3 plus 2 root 3, here again you keep the root 3 as it is and you add the numbers 3 and 2 together, giving you a 5. If it was subtraction between these terms, again you keep the root 3 and you subtract. It's 3 minus 2 giving you a 1. What if you're adding A plus B? You don't have a particular answer for it. It just remains A plus B. But if you had A plus B plus A plus B, then your answer will look like 2A plus 2B. So here you are combining the A terms, so A plus A is 2A, and the B terms, so this is your final answer. This is the same approach that we do with surds. Root 2 plus root 3. The answer just remains the same. It's just root 2 plus root 3. What happens when it is of this form? Here we combine the like terms, that's a surd which has the root 2, and here you have root 3 plus root 3. So together the final answer will be 2 root 2 plus 2 root 3. Now, understanding the basic concepts of how to combine the terms, the surds, during an addition or a subtraction, we'll move on to level 2 questions where you have simplify. So if you look into those terms, you can see that you have a root 2 here and it's a root 8. Now 3 root 2 cannot be further simplified, so I'll start with root 8. Now 8 can be factorized as 2 times 2 times 2. 2 2s are 4, 4 2s are 8. So square root of 8 can be written as square root of 2 times 2 times 2. Now when you look at this terms, 2 times 2. So 2 times 2 is 4 and square root of 4 is 2. When you have the same term repeated twice inside the square root, so you can just remove the square root or you can take one term outside. So this becomes 2 and there is 2 inside the root that remains. So this is how root 8 can be written. So root 8 is going to be 2 root 2. If you need some clarity here, see square root of 2 times 2 times 2, which is square root of, I have 2 times 2, which is 4 times 2. Square root of 4 is taken as 2 and you have the remaining 2 inside. That's another logic of understanding it. Going back to the question, 3 root 2 minus, now I will replace root 8 with 2 root 2. Now my final answer, I'll have the root 2 there and 3 minus 2, which is 1 root 2. This is my final answer. Or you can just write it as root 2. Question B, simplify. Square root of 32 plus square root of 98. Now in this case, first I'll just prime factorize 32. So 32 can be written as 2 times 2 times 2 times. So square root of 32 can be written as square root of, so I have two 2's outside and inside I have a root 2. So finally my root 32 can be written as 2 times 2 is 4 root 2. So I'll be replacing square root of 32 as 4 root 2 plus, now I have square root of 98. I'll do the same process. So 98 is equal to 2 times 7 times 7. So square root of 98 is going to be square root of 2 times 7 times 7. I have 7 times 7 here. It's 7 that's going to be out of the square root sign and the 2 remains. Let me put this value to replace square root of 98. 7 root 2. Let me just clean all this place. Now I have a root 2 in both these terms and I'll add 4 plus 7 giving me a 11. So this is my final answer. In level 3 we'll be simplifying the question cube root of 625 minus cube root of 40. Since you have different terms inside the surds and both are cube roots, so first I'll start with factorizing 625 and 40 as we did in the earlier question. So 625 is written as 5 times 5 times 5 times 5. So here we are dealing with the cube root of 625. So which is again equal to the cube root of 5 times 5 times 5 times 5. In the previous question, in the square root, I hope you remember me pulling out one term that repeated twice. Since it's a cube root, I'll be considering 3 terms. Okay, so if I have the same 3 terms, then one jumps out of the cube root. So this is going to be 5, and inside the cube root you will have this remaining 5 there. So this is cube root of 625, which is 5 cube root of 5. Now factorizing 40 on the other side. So cube root of 40 can be written as cube root of 5 times 2 times 2 times 2. I have the term 2 repeated thrice inside the cube root. So the 2 jumps out of the cube root, which is equal to 2, and inside the cube root I have the 5. Minus, I will replace this cube root of 40 with 2 cube root of 5. So my final answer will be, I have cube root of 5 here and cube root of 5 here, so that remains, and the coefficient is here 5 and minus 2, so that's going to give me a 3. This is the final answer. You can just pause the video and try to solve this question by yourself and check the answer at the end.